Hi, I am B. Janardhan Reddy. In this video, I am going to explain an activity to show that the sum of the potential differences of the bulbs or resistors is equal to potential difference across the combination of the resistors. So, in this activity, I will connect three bulbs in series in a circuit, and the voltage of the battery gets divided between the ends of each bulb, and it will be proved that V is equal to V1 plus V2 plus V3. Here V is the potential difference between terminals of the battery. V1, V2 and V3 are the potential differences between the ends of each bulb. So when the bulbs are connected in series in a circuit, the battery voltage will get divided across the ends of each bulb depending upon the their resistances. And it will be shown in this activity that V is equal to V1 plus V2 plus V3. Isn't it? So here is the aim of the activity, to show that the sum of the potential differences of the bulbs or resistors is equal to potential difference across the combination of the resistors. To do this activity, the material required is, you see here, different bulbs, multimeter, ammeter, voltmeters, batteries, switch, connecting wires. Here you can see the material also. These are the different bulbs. That means the resistances of these bulbs are different. And here is a multimeter which is used to measure the resistance of each bulb. And this is an ammeter, and here I am using milliammeter which measures the current in milliamperes. And this is a voltmeter. I will use such 3 voltmeters to measure the potential differences between the ends of each bulb. Okay. Next, these are the two 9 volts batteries. I will connect these two batteries in series so that I will get 18 volts potential difference. This is a switch and these are the connecting wires. Now I will make a circuit by using this material. Before going to make the circuit, first I will measure the resistances of the bulbs by using multimeter. Here is the procedure to do this activity. Step 1. First we have to measure the resistances of the bulbs with a multimeter, and I will let their values as R1, R2 and R3. So these are the 3 bulbs we have taken. By using the multimeter, I will measure the resistance of each bulb. So first I will switch the multimeter on. I will place this knob at 200 ohms range here so that it can measure up to 200 ohms. Now let us measure the resistance of the first bulb here. It is 1.0 ohms. So the resistance of the first bulb, say R1 is equal to 1.0 ohms. The same way I am going to measure the resistance of the second bulb. See here. So the resistance of the second bulb is 1.5 ohms. Let its resistance as R2 is equal to 1.5 ohms. Now I am going to measure the resistance of the third bulb. It is 2.0 ohms. So the resistance of the third bulb, say R3 is equal to 2.0 ohms. Okay. Turn the multimeter off. Now I will measure the potential difference between terminals of the battery. That is, I am going to measure the battery voltage in step 2 by using the same multimeter. And this is the battery in which two cells have been connected in series. So this is the multimeter which I am going to use to measure the potential difference between the terminals of this battery. So turn the multimeter on. Here I am placing the knob at 200 volts. Okay. Now let us measure. It is 18 volts. So the potential difference between the terminals of the battery is 18 volts. Let us note down this value here. So V is equal to, that is battery voltage, V is equal to 18 volts. Now I will make a circuit. In step 3 I am going to connect a circuit, and I will measure the potential differences between the ends of each bulb and note them as V1, V2 and V3. First I will make the circuit. You see here, this is the battery, switch, ammeter. All these are going to connected in series, and here are the three bulbs. First bulb, second bulb, third bulb. The resistance of the first bulb we have seen so far, it is 1.0, R1 is 1.0 ohms, and the resistance of the second bulb R2 is equal to 1.5 ohms, and R3, that is the resistance of the third bulb, we got it as 2 ohms. Now I am connecting these three bulbs in a series. See how I am connecting all these components in the series manner. See here, this bulb has two terminals, and I have connected the negative terminal of the battery to one of the terminals of the bulb, and the second terminal, the other terminal of the bulb, has been connected to the first terminal of the second bulb, like this. And this type of connection is called as the series connection. That means all these bulbs have been connected in series. So when the components are connected in the series fashion, there is only one way of current to flow through them. That means the same current will flow through all the components. Okay. Now In order to measure the potential difference between the ends of each bulb, I will connect the voltmeter parallel to them. See here. Here I am using this voltmeter to measure the potential difference between the ends of this bulb. And remember, ammeter is always connected in series in the circuit, whereas voltmeter should always be connected in parallel to the load. Here the load is the bulb. Okay, and I am going to connect one more voltmeter parallel to this bulb. Okay, so bulb 1, bulb 2 and bulb 3, and these are the voltmeters which have been connected in parallel to the bulbs in order to measure the voltage between the or potential difference between the ends of the bulbs. Okay, now I will turn the switch on, then current is flowing in the circuit so that bulbs are glowing. So how much current is flowing in the circuit? You can see here 400 milliamperes current is flowing in the circuit, and when current flows through a resistor, some voltage will get developed across the ends of the resistor. So here the filaments are the resistors actually, and according to Ohm's law, when I current is flowing through a resistor, or the potential difference developed across its ends is V equal to IR. So some current is flowing through these three bulbs, that means same current is flowing through the bulbs, but depending upon the resistance of each bulb, the potential difference will be developed across its ends. So here you can see the potential differences between the ends of each bulb. That means 400 milliamperes current is flowing through all the bulbs, and potential difference developed between the ends of the first bulb, say V1, it is here 4 volts, isn't it? So from here to here it is 5 volts, means 1 volt. 1 volt means 2 divisions. So it is 8 divisions. 8 divisions means here 4 volts. So V1 is equal to 4 volts. Similarly V2 is equal to 6 volts, because and this reading, this needle is showing here 12 divisions, means it is 6 volts, and here it is 16 divisions, it is showing, means 8 volts. So V1, V2, V3, V1 equal to 4 volts, V2 equal to 6 volts and V3 equal to 8 volts. The potential difference between the ends of the first bulb, say V1 equal to 4 volts, and the potential difference between the ends of the second bulb, say it is V2 equal to 6 volts and here V3 equal to 8 volts. If you sum up these three potential differences, V1 plus V2 plus V3, 4 plus 6 plus 8, we get 18 volts. This is nothing but the potential difference between the ends of the combination, otherwise the potential difference between the terminals of the battery. So see here, sum of the potential differences of the bulbs V1, V2, V3, we got V1 as 4, V2 as 6 and we measured V3 as 8. So it is 18 volts. This is equal to battery voltage, or V equal to 18 volts. So V is equal to V1 plus V2 plus V3. What is V? V is the potential difference between the terminals of the battery. V1, V2 and V3 are the potential differences between the ends of the bulbs. So what is the result of this activity here? The sum of the potential differences of the bulbs or resistors is equal to potential differences across the combination of the resistors. Across the combination of the resistors are is nothing but battery voltage. Okay. Thank you.